This is a rather tricky case again, and we start by looking for the QRS complexes first. And we know that these are the most peaked parts of the curve, and this is one of them, for example, here, and one is here. So, and this one too. So we have 3 QRS complexes. This is number 1, number 2, number 3. And we know that in a certain distance from the QRS complex there should be a T wave. So somewhere here we expect a T wave, right? And here too. And the same would be true here. Looking at these 3 circles, we see that these so-called T waves are not looking alike. So at first glance we cannot really say what is the T wave or whether there is something else hidden in it. Okay, let's go to the next waves. Here is one wave that's very clear that this is neither QRS nor T, so this must be a P wave. Same thing here, must be a P wave, and here too. And we see that these P waves have a very interesting shape. They are rather peaked waves, and when we look at the tracing from one end to the other, we see that there is a wave that is rather similar to the P wave, like here, or even here, that there is another wave that could be a P wave. And we know from the example just a few tracings back that the P waves usually come at regular intervals. So there's one P wave here, one P wave here, one P wave here. And now we must say that what we have called T wave here is a mixture of a P wave plus a T wave. And the same thing is here. There's a P wave over on top of a T wave. And here we have a P wave on top, a P wave on top of a T wave. This is a very difficult case. And it is very rare that we have this superimposition of T and P waves, and I'm sure as long as we go along with the tracings you will get better and better.